everybody, this is Miss Bufford, and in this video we're going to talk about calculating percent error. So our learning goals here are to be able to calculate percent error between an expected value and an experimental result. So why is it important to be able to calculate percent error? This is really important because a lot of times in chemistry we perform experiments and we have done calculations and we know exactly how much of a product we should be able to produce. But in chemistry, we never actually really produce as much as we expect that we will. And so if you are, let's say you're in industry and you're trying to produce a certain chemical for somebody and they need a certain amount, if you know how much error is in a process that you normally use or you normally follow, you can make adjustments in your calculations so that you can produce what you are aiming to produce. So we're going to talk about how to calculate percent error because it's going to be useful later this year. So here is the formula for calculating percent error. You can see that percent error is equal to the absolute value of the experimental value minus the accepted value divided by the accepted value again and then multiplied by 100. So our experimental value is always going to be the amount that you get or the measurement that you got based on your experiment. And the accepted, sometimes it's called the expected value, is the measurement or the amount that you expect to be able to produce based on calculation or maybe based on looking up information somewhere. So experimental value always comes from experimentation, and the accepted or the expected value always comes from some sort of calculation or from looking a value up somewhere. All right, and for our class, percent error is always going to be positive. So we have these absolute value bars here on either side of the top of our fraction in that equation, and that's just to make sure, because sometimes our experimental value, or most of the time, is smaller than our accepted value. And we just want to make sure that we're always producing a percent error that is positive in this case. So let's go ahead and do an example. Kate has been in the lab all day trying to collect data for an experiment that she's replicating. According to her calculations, she expects to produce a volume of 2 liters of oxygen gas. When she's finished, she ended up with 1.8 liters of oxygen gas. Calculate the percent error in her result. So let's go ahead and put our formula up here again. And the first thing we do before we try to plug this into any formula is we're just going to identify which value is our experimental value and which one is our accepted value. So remember, the experimental value, it always comes from experiment. And so this says here when Kate finished, she ended up with 1.8 liters of oxygen gas. So that is her experimental value because that is what she got when she performed this lab or procedure. All right, and then the accepted value, remember that always comes from some kind of calculation or looking it up somewhere. And according to her calculations, she expected to produce 2 liters of oxygen gas. And so that's going to be our accepted or expected value there. All right, so now let's go ahead and plug these numbers into our formula. And there you see we've got our 1.8 liters right here. And then our 2 liters, which is our accepted value, goes up here on the top and in the denominator as well. And then we multiply that by 100, and we can see that Kate had 10% error in her whole process of how she produced this oxygen gas. All right, so now if she knows that she needs to produce a certain amount of gas and she's using the same process, then she knows she typically has about 10% error. So if she needs to produce more, then she can adjust her calculations to account for that 10% error between what she expects to get and what she's actually able to produce. Right? If you have any questions, don't hesitate to contact me either through email or next time we meet in Teams. Thanks for watching Bufford Chemistry. Subscribe to my YouTube channel for more chemistry help.